Hey programmers, Alvin here. Right now I want to go over a JavaScript solution for this how high problem. So let's jump right in. Hopefully you watched the approach video already because the code is actually really short. And so the trick is to make our base case about the null node, or really like the empty tree. We can say that the empty tree has a height of -1, and from there I can build up my actual logical heights, right? So here we'll just jump right in and we'll check, hey, if the node is equal to null, so it's triple equals, then it must have a height of -1. Cool. And I think what's also great about that is that actually might be an explicit test case. Yeah. Looking at test 04 over here, if they actually pass us a null value, we should return -1. So that's kind of a big hint there. But back to our problem. So that's our base case. Now I want to actually work in the depth first part, the recursive part. So whenever I work through some code, I always know that I'm going to have some core patterns. So I'm just going to lay those out there, although I'm not sure how to actually put it all together yet. So by now you should probably recognize that if we're doing this depth first, I must have a recursive call. I'm going to call on node.left and have a symmetric call for node.right. Cool. And from there, I'll think about what type of data these calls return, right? So because I'm solving this recursively, they must return numbers, right? And those numbers represent the height of the left subtree and the height of the right subtree, respectively. So maybe just for some clarity, you don't have to though, but I'll create some intermediate variables, and I'll say my left sub, we'll say maybe just left tree height equals that, and likewise for my right tree height. Cool. So I have the height of my left subtree and the height of my right subtree. And the key pattern is when it comes to calculating the height of our subtree as the parent, I must choose the max or the most between my two children. So I'm going to compare the left height and the right height. So if you wanted to, you can totally do like a little conditional logic like this, right? If left tree height is greater than right tree height, then you can, probably return some value like that. My favorite way to implement this pattern, it's pretty clean, is to just use math.max. So I can say math.max between two values. So give me the maximum among my left tree height and my right tree height. And I can store that in a variable if I wanted to, but really I just want to take that max value between the left and right and return 1 plus that maximum. So remember, if I'm the parent and these are my children, there is one edge that separates, a parent from its child or either child. So maybe you're unfamiliar with the math.max, never want to make it a mystery, so I'll quickly just review that. So in isolation right now, if I had like math.max, I pass in some values like, 5, we'll say 2 and 12 and 11. That'll just return me back the single value that is the maximum, right? So I expect to see 12. I'm just running this as a plain old file, not running the tests yet. So hopefully I get a nice little 12 here. Cool, there it is. And so that's all I'm doing with this call. So it kind of substitutes for the conditional that you would have wrote, the if statement. And another key thing is definitely you want to add 1 to it over here, right? If I don't do the +1, then I know for a fact that any height I would return is just like -1. So I need to start growing my heights, counting the edges basically. So that's why I do a 1 plus over there. So let's give this a shot. Run through a few test cases. Bam! And there we have our solution for our how high problem. So really just a spin-off of our depth first reversal, utilizing this nice call to max. So definitely try this problem on your own if you had some trouble with it. It's really important that you master this problem as we look at other more advanced tree problems. I'm going to consider this one a really core pattern.